Hello and welcome back to this continuation of my previous video where we were going over variables. Now we're going to talk about some basic math and coding and pick up where we left off. I had to put a cut in last time because the video was running a bit long. So let's go ahead and roll the intro and get into it. Alright, so let's move on. We're going to talk about basic math and coding. So we can use basic math operators to perform calculations on our data, including what's stored inside a variable. I'm going to go ahead and copy this pre-typed little table I have out here. So our most common arithmetic operators that we'll see are addition, subtraction, multiplication, division, exponential, and modulus. Addition, using the plus sign, pretty simple. Subtraction, also pretty simple, uses the minus sign. Multiplication doesn't use an X, it uses the asterisk, or a star, you might think of it as. If you have a number pad on your keyboard, that's the best way to find both multiplication and division symbols. Otherwise, the asterisk is above your 8 on your keyboard. And then division is going to be a forward slash. It's denoted forward slash because the top of it is leaning forward to the right. If it were leaning back to the left, then that's a backslash. That's in case you are ever confused about which is which. Forward slash is the same button as your question mark next to your right-sided shift on your keyboard. And then there's exponential. This is the caret key. This is above the 6 on your keyboard. That is, of course, like, 2 to the power of 2, or 2 to the power of 3, why not? However you want to do that. So that's just exponentials. And then modulus is a percent sign. So modulus might be foreign to a lot of you, but it has a lot of uses in programming. It's great to learn about because of that. So modulus returns the remainder of dividing two numbers. So let's give an example. So let's say 17 modulus 5. This is going to equal 2, is what this is actually going to come out to. Why is that? Well, 17, if we divide 17 by 5, right, and we're looking at this, 5 can go into 17 how many times? 5 can go into 17 3 times, right? So 3 times 5 is 15. And then, of course, compared to 17, that has 2 left over. And that's where we get the 2. It's the remainder when we do that division. All right, so 5 can go into 17 3 times with 2 left over, so we get our remainder there. There's one really common use that I get out of modulus, although there's actually a lot of good uses for it, as I mentioned. But the common use that I've found to use this is to determine if a number is odd or even. So for example, let's say we have result as a variable, and let's do 14 plus 98 minus 32 times 12 divided by 3. Right, so this math gets pretty complicated. By the way, there is an order of operations here, so like it'll do multiplication, then division, then addition, then subtraction, unless you put things into parentheses, but that's beyond the scope of this. It's just normal math. So now let's determine if our result is odd or even, right? And the way you would do that is you would take our result modulus 2, and if our odd or even result ends up being 0, then our result number, whatever the result of this mathematical equation here, is going to be an even number. And why is that? If you divide an even number by 2, you'll have no remainder, because any even number can be divided by 2, completely split in 2 evenly, right? It's an even number. If you divide an odd number by 2, you're always going to have a remainder. It might not be 1, it might not be 2, it might not be 3. It could be a number of different numbers, obviously. But dividing an odd number by 2 will always result in a remainder when you use modulus. You're always going to get either a 0 or a remainder number when you divide it by 2. So that is how you can determine odd or even. Like I said, super common in programming to need to know a lot of that stuff. Also super common in programming to want to add, subtract, or multiply a value stored in a variable. So scores, timers, currency, etc., right? Maybe a scoreboard shows a player's score and it increases by a certain amount over time. Maybe they earn a multiplier to their score if within a certain time frame left in the round. So To increment, let's go over that now. So this is increment. That basically just means to increase the value of a variable. So for example, to increment a variable by 1, we can do, let's just use x again here. We can use x equals, we're going to reassign x to itself and we'll add 1. So that will increment our x value by 1. So we're still using the assignment operator here. What we're doing is we're reassigning x to itself, adding 1. So another way to write this is to actually do just x plus equals 1. This does the same exact thing. So basically anything on the right side of our assignment operator is going to be then added, in this case, to our x, and it's going to save that value into itself. So that's kind of a little shortcut. You'll often see me doing this a lot more. You'll often see a lot of people doing this. It's just more concise, just a little easier to type. So then there's also decrement. So to decrement something is to obviously subtract a value by a variable. So for example, we can say x, and we'll use our assignment. We'll again assign x to itself subtracted by 3 or 5 or whatever. So if we're doing that now, we are subtracting 5 from x and then assigning that result back into x on itself. And again, you can do this easier by saying minus equals 5. So you can use this method here with all of the mathematical operators as well. So you can even do modulus equal if you want, divide equal, multiply equal, exponent equal. And then it'll just use this value as whatever would normally be the value on the other side of where you would use that mathematical operator anyways. So when might we want to increment or decrement? Well, let's say coins, right? Player has some coins. We'll say local coins, we'll initiate it at 0, initialize it at 0 here. So when a player collects coins, we might want to say coins plus equal 1, right? So we're incrementing their amount of coins by 1. Maybe they have something on them that actually multiplies the amount of coins they get per coin. Well, you could just, obviously add whatever it is there, or you could then multiply, this result by, whatever multiplier you might have. That you might have as another variable. Oops, I did not. There. And if that multiplier is just 1, then it's going to be 1. If it's 2, then it's going to be 2, and so forth and so on. So that's a good use case for incrementing. When might you use decrements? Well, let's say we have a health value here for a player, which they have their own health value in their humanoid, but let's just say we're making our own. So with their health value, maybe they take some damage. Maybe they take 20 damage. So we'll say that their health is now going to be decremented by 20. And again, this is the same as saying health and setting the assignment to health minus 20. So this and this are exactly the same thing. You can see why, especially if your names are a little longer, and health is not even that long of a name, but how that's just a lot shorter and more concise, easier to write. So you could possibly use multiplication to determine the amount of money you have. So let's make a variable here called quarters, and we'll set that to, 72, why not? And then we'll say our money value is equal to our quarters, and obviously we'd multiply that by 0.25, because that's how many quarters we have. They're 25 cents each, and that's how much money we would end up with. Maybe you would use division to divide a money reward among a number of players involved in earning that reward. So let's say you have a number of players. We'll just do 5 players have been playing. They've earned this reward together. So now our reward is going to equal, let's actually make it, so let's actually do our reward. Let's make this equal to, I don't know, something crazy like 86. It's not that crazy. And now we can say, let's use our money value, why not? Let's say that our new money value is equal to our reward divided by the number of players, right? And that's how you could divide up that reward to that person. Exponentiation could be used if you're calculating the population in like a simulation game or something, and it's doubling every round, right? So let's say we have a population of 100, why not? And then every round our population is going to be using the exponential of to 2, right? It's gonna double our return. So we'll do population exponent 2, and of course, yes, you can still just do the population exponential caret there and the number 2, and that will work the same as well. All right, finally, let's go over another possible example using modulus just to drive that home. So we could use this to determine which specific day of the week it is from a number of days that have passed. So let's go ahead and make a total days variable here. So we'll say 272, why not? 272 days have passed. And then we'll make a day of week variable here, and we're gonna set this equal to our total days modulus 7, because there's 7 days in the week. And the way that this would work is if we have Sunday as day 0, Monday as day 1, Tuesday as day 2, Wednesday as day 3, Thursday is day 4, Friday is day 5, and Saturday is day 6. We can actually, let's even pull up a calculator on this, because you can use modulus if you're using a scientific calculator, which is nice too. So for example, we start the game, we're on day 0. So if we do 0 modulus 7, and I'm just using my percent on my keyboard and typing it out just like I would, just like I did in the actual code editor there. If I hit enter, you'll see that this gives me 0. So that means our first day of the week is going to be Sunday. If I do 1 modulus 7, okay. If I do 1, did it again. If I do 1 modulus 7, we get 1. Guess what happens if I do 2 modulus 7? That's right, we get 2. And this will carry on, right? So eventually we get to the last day of the week, which would be 6 modulus 7, which is going to be 6. If I then go to 7 modulus 7, so now 1 full week has passed, you'll notice that it goes back to 0, right? And again, if I do 8 modulus 7, it goes up to 1, so we'll continue counting that way. So that's a really cool way. So if we actually want to know, for example, which day of the week 272 days into a year is, as long as the year started, you know, as long as the game starts on a Sunday, we would do 272 modulus 7, and it would end up being a Saturday, as a matter of fact. Cool, it's the weekend. All right, so that was a relatively simple, straightforward video, builds on our foundations of how to code. In the next video, we're gonna go over another foundational principle, and that's gonna be going over functions and how that works. We're gonna need a lot of that when we start talking about certain things like module scripts that I really wanna get into. But otherwise, make sure you subscribe, leave a comment, hit the like button if you liked it, hit the dislike button if you disliked it. Let me know what you think I could do better if you do dislike it. Critical feedback is always important for me. Otherwise, I will see you guys in the next one.